Good morning, students. Hope you are enjoying our online classes. Students, today we are going to continue with the chapter Gravitation, part 2. And under this, we are going to study about the Kepler's law of planetary motion. As you can see in the pictures also, I have drawn some planets and the motion of the planets around the sun, this orbital motion. And the second topic will be the free fall, means when the object falls under the action of gravity force. What are the properties of that object? What will be its acceleration? What will be its velocity? So watch the video carefully and we are going to explore all these things today. Before starting, let's look upon the learning outcomes of the day. Students, after the completion of the topic, you will be able to, number 1, state Kepler's law of planetary motion, define free fall, derive the formula for acceleration due to gravity, calculate the value of g on the surface of Earth, and enlist the factors on which g depends. Now what's this g? Actually this is the value of acceleration due to gravity. It is denoted by small g. वैसे हम acceleration को a से denote करते हैं, but the acceleration due to gravity we denote it by small g. And today we are going to learn about this g in detail. And as far as Kepler's law of planetary motions are concerned, these laws are only for the reading. We are going to just read these laws. We are not going to ask any question in the exam related to this topic. This is just for your understanding what are the various laws of Kepler that have helped the Newton to formulate the law of gravitation. Okay? And what about free fall? As the name says, free fall means when the object is falling freely, and we are going to study the various factors under which the object falls freely. Okay, so watch the video carefully and check where you have achieved these outcomes. Students, as you can see here, I have drawn one shape. This shape is yes, oval shape. Yes, oval shape. And actually we call this shape as elliptical shape. And this is the shape of the orbit of the planets around the sun, isn't it? Planets move around the sun in the orbit that is elliptical shaped. Okay, elliptical shaped orbit. This is the shape of ellipse. So let's discuss the Kepler's law of planetary motion. The first law, it is the law of orbits. And according to this law, every planet moves around the sun in elliptical orbit with the sun at one of the foci of the elliptical orbit. Now, what is elliptical orbit? It is clear. As you can see here also, elliptical orbit, this green line, red line, yellow line, all these are ellipse, and the planets move around the sun in this elliptical orbit. Okay, now what about this foci? Foci is the plural of focus, and when the planets move around the sun in the ellipse, then the sun will be present at one of the focus. Okay, there are two focus of the ellipse and sun will be present at one of the foci. Okay, sun will not be at the center. Clear? This was the first law of Kepler. Just understand it. What is that law? Okay, what is this law? And need not to learn it, just understand it, that every planet will move around the sun in the elliptical orbit and the sun will be present at the focus, any one of the focus. Now, Kepler's second law, this is the law of areas. Now what is this law? The line joining the planet to the sun, just make an imagination, you have to draw the line joining the planet to the sun. It sweeps over equal areas in equal intervals of time. Means when planet is revolving around the sun, then the area it sweeps, aerial velocity की बात होगी, अब ध्यान से सुनना, when the area it sweeps, जितना ये area cover करेगा, suppose planet is at point A and it is covering this distance and reached point B, then the area it has covered is this triangle, isn't it? What the law says, the line joining the planet to the sun sweeps equal areas in equal intervals of time. Means if we take the two positions of the planet, one is planet is at A and it is moving to B, and other position is planet is at C and it is moving to D. Now if the areas are equal, if the area swept by the planet, this area and this area, if the areas are equal, then that means the planet will move from A to B or from C to D at the same time. उतना ही टाइम लगेगा जितना उसको A to B जाने को लगेगा, उतना ही टाइम उसको C to D जाने को लगेगा, अगर उनका बीच का जो एरिया स्वेप्ट बाय द प्लैनेट है वो इक्वल है. दिस वाज सेकंड लॉ. So what conclusion can you draw from here? That means the planet will not move with the same speed in the ellipse. यहाँ तो बहुत कम डिस्टेंस कवर किया है, उतना ही टाइम लगाया. यहाँ पे उसने बहुत पेरिजी पे बहुत डिस्टेंस कवर किया है, पर उतना ही टाइम लगाया. That means here somewhere the planet is faster and at apogee position the planet is slower. Let's see. Area of SAB, this area, is equal to area SCD, this area, ये वाला area, ठीक है? For the given time, if the time is same, then the areas will also be same. That means the second law tells us that the planet does not move with the constant speed. It speeds up while approaching the nearest point called perigee. Here it will speed up and cover a larger distance so that the area is equal. And it slow down while approaching the farthest point called apogee. If it is at apogee, then it will be slower down because it is already very far from the sun. So area covered will be very large. So it has to drop its speed so that this area is equal to this perigee area. Okay? Therefore, distance covered on the orbit within the given interval of time at perigee is greater. Distance covered will be greater at perigee and then at the apogee for the equal area swept. Okay? Area will be equal, but the distance covered by the planet will be different because here planet is at far points. Okay? Just try to understand this law. Okay? Now next, Kepler's third law. This is the law of periods, and this law is very, very important because Newton formulated its gravitational force of attraction between the two bodies that we have studied in the previous class. Newton has formulated that formula by using Kepler's third law, that is law of periods. The square of the time period means the time for one revolution. The square of the time period of revolution of a planet around the sun is directly proportional to the cube of the mean distance of the planet from the sun. Means कितना दूर है planet sun से, वो distance जो है उसका अगर हम cube कर लें, and the time period जो है planet का, if we make a square of it, then both these are proportional to each other. Time period means the time taken by the planet for one revolution. Okay? And this t square is directly proportional to r cube. Time period, square of time period is directly proportional to the cube of the mean distance of the planet from the sun. Distance between planet and the sun. Okay? Kepler has given these laws, but he could not explain the motion of planets, and that was explained by Newton, as I have already discussed with you. And he was the first person, Newton was the first person who has formulated the formula for gravitational force. So Newton has used this Kepler's third law. Now we have learnt about the Kepler's law. Let's come to the next topic. Yes, this is free fall. We have learned that Earth attracts the objects toward it due to the gravitational force. This we have studied in the previous lecture. that earth will attract the objects? This is because of the gravitational force. Now whenever the object falls towards the earth under this force alone, we say the object are in free fall. I am repeating, means whenever the object is falling towards the earth under the action of only the gravitational force, जब सिर्फ gravitational force उस पे लग रही है and object is falling freely, we call it as free fall. Okay? So free fall means when the body falls from the height towards the earth only under the influence of a gravitational force with no other force acting on it, then the body is said to have free fall, and we call the body as freely falling body. Galileo proved that the acceleration of the object falling freely towards the earth does not depend upon the mass of object. What does this mean? When the object falls freely, then the acceleration with which it is moving, it will be same. But does it happens in the real life? पहले समझें इसको, फिर हम बात करते हैं इसके बारे में. Here Galileo done, he took one feather and one 5 rupee coin. 5 rupee coin is heavier than the feather, but he dropped both these and found that both these falls at the same time, but under the condition that this glass tube should have vacuum inside. There should be no air to resist this. Then the objects, either it is heavier or lighter, it will fall at the same time. Imagine that vacuum is created by evacuating the air from the glass jar here, and the feather and the coin will fall with same acceleration and reach the ground at the same time. It happens. It will happen. But if there is air resistance in normal life, as we see, the feather will take time to fall and the coin will fall at once. It will take time because of the air resistance. Okay, we'll discuss it later. But if it is vacuum, no other force is acting, only the gravitational force is acting, then the object will fall at the same time irrespective of their masses. चाहे वो बहुत 1000 kg stone है, चाहे वो 1 kg stone है, both the stones when fall simultaneously, if there is vacuum, no other force acting, then both will fall at the same time. Means they are accelerating equally. Let's perform the activity. Take a sheet of paper and stone. Obviously, sheet of paper is lighter than the stone. Drop them simultaneously from the first floor of the building. You can perform it at your places. What will happen? Drop means you will not apply any force. You will just leave them. ऐसे हाथ छोड़ देना है, उनको छोड़ देना, नीचे की तरफ फेंकना है. But you will not apply any force. You will just drop. Observe whether both of them reach the ground simultaneously. But no, we see that the paper reaches the ground little later than the stone, isn't it? Paper will take time. Why? The answer is here. This happens because of the air resistance, as I have already discussed. The air offers the resistance due to the friction to the motion of the falling objects, and the resistance offered by the air to the paper is more because paper covers larger area than that of a stone. So air resistance to the paper will be more than the air resistance offered to the stone, because stone is very compact, very smaller. If we do the experiment in the glass jar from which air has been sucked out, as we have seen in the previous slide, then both paper and stone will fall at the same rate. This activity is given in your NCERT book also, and we have done this activity in the previous class also when we have studied about the fluid friction. Remember that? तो air resistance की वजह से sheet will take certain time to fall. Otherwise, if it would have been a vacuum, then both sheet of paper and the stone would have fallen at the same time. So let's explore further about the freely falling body. Is there any change in the velocity of freely falling body when the body is falling freely? Just think over it. As we have seen, when the body is falling freely, then there is no change in the direction of motion. It will fall directly towards the earth, no change in the direction. But due to the earth's attraction, earth is applying some force, F is there, force is there will be the change in the magnitude of velocity. Velocity की value change होएगी. And change in velocity means acceleration. So, when the body is freely falling, it will be accelerated. And this acceleration is not the simple acceleration. This acceleration is a special acceleration because this acceleration is due to the Earth's gravitational force. So, we call this acceleration as acceleration due to gravity. I am repeating, it is the acceleration with which the object will fall freely under the action of only the gravitational force of Earth. This is the acceleration due to gravity. We denote it by the symbol G, and the SI units of G are same as that of the acceleration because it is acceleration only. So its units are meter per second square. We are going to learn further about this small g in our next slide. Let's see. Acceleration due to gravity. This is g, as we have discussed. Definition is, acceleration due to gravity is defined as the uniform, the constant acceleration produced in the freely falling body due to the action of gravitational force of the earth. Okay? And its value is constant for the earth. It is 9.8 meter per second square for earth, and different planets will have different value. From where this value has come, we will discuss later. Now here, calculation of the acceleration due to gravity. How can we derive the formula for this g? Let us see. Suppose a body of mass m is placed on the earth of mass m, capital M. Now earth mass is capital M and the body's mass is small m, and the radius of earth is r. Okay? According to gravitational law that we have already studied, universal law of gravitation, F is equal to, yes, G mm upon r square. Okay? Now this force is exerted by the earth and it will produce the acceleration, and we know the formula from Newton's second law, F is equal to ma. याद है ma, and here the acceleration is g, so we write the formula F is equal to mg. ठीक है, अब दोनों ही फोर्सेस हैं ये हमने ग्रेविटेशनल फोर्स ऑफ अर्थ की बिकॉज ऑफ द एक्सेलरेशन ड्यू टू ग्रेविटी g we have applied this formula, and from universal law of gravitation the force of attraction is this, so both the values are equal. We will equate them. When we will equate them, then this small m will get cancelled and the value of g comes out to be capital G capital M upon r square. The distance between the earth and the object is r, radius of the earth, because object is very small, so the radius of the object is negligible. We are not taking that radius, hardly it will be few centimeters or meters, but in front of radius of earth this small radius is ignored. So we take the distance between earth and the object as the radius of earth. So value of g is gm upon r square. Now you can see capital G is also constant, gravitational constant. Mass of earth is also constant because earth quantity of matter जो इसमें है वही रहेगा इसमें. Mass of earth is constant and radius of earth is also the same. So all the values are same, so g will be having a particular value. Let's calculate. If we know all these values, we can find the g also. So अब तक हमें formula of g पता चल गया है. अब हम find करेंगे value of g on the surface of earth. Let's see. We know the mass of the earth as this you have to remember, 6 into 10 raised to power 24 kg. Just commit to your memory, you have to learn it. Radius of earth is 6.4 into 10 raised to power 6 meter. And the gravitational constant is the value we have discussed in the previous lecture. It is this 6.67 into 10⁻11 Newton meter square per kg square. Now all these values, if we substitute these values here in the formula of G, you can see G m upon r square. R is repeating twice. So all these values 6, 6.4 and 6.67 almost they are equivalent to 6. तो ऊपर भी 2 बार 6 आएगा, नीचे भी 2 बार 6 आएगा, तो वो तो कैंसिल हो जाएगा. Just see the values of 10 power 10. Here for m the value is 24 and for g the value is -11. G and m इसकी power -11, 10 raised to power -11, and for m the power is 24, 10 raised to power 24. So while solving both these, we get bases are same, powers are added, and we get the value as 13. And in the denominator, we get this is a radius is 10 raised to power 6. So if we square it, we get 10 raised to power 12. So in the numerator we have got 10 raised to power 13. In the denominator we get 10 raised to power 12. So we can cancel. We can, bases are same. ये division का sign है, तो powers will be subtracted, and we get approximately the answer 10. You can solve it and you will find that the value of G comes out to be 9.8 meter per second square. We will discuss this value in the live class also. Okay, you solve it yourself. We'll discuss with you whether you get this value or not. And for the simplified calculation, जो मैंने अभी आपको approximation से बताया, for simplified calculations we take G as 10 meter per second square. Okay, so we have studied about small g, we have calculated the value of g. Now beta, there are some variations of g also. Although its value is 9.8 meter per second square, but there are certain variations. Let's see, because that value that we have studied, that g is 9.8 meter per second square, that is the value on the surface of Earth. But what happens if we move above? Means G will decrease with altitude, means height above the Earth's surface. If we move above the Earth's surface, move some height, काफी kilometers ऊपर चले जाते हैं, then the value of G will decrease. How it decrease? As we have seen the formula, Gm upon r square. Here r distance will now increase. We cannot neglect this distance as we have neglected in case of the object lying on the surface of Earth. Now the object has moved several kilometers, several distance, कुछ kilometers उसने cover कर लिए हैं, तो we have to take this h into account. So r will be r plus h now, distance between two. So denominator has increased. That means the value of g will decrease with height. ठीक है, आपको बस याद रखना है g will decrease with height. कैसे वो मैंने आपको समझा दिया है. ठीक है. Now next is g will also decrease with depth. If we move inside the earth, then also G will decrease. Kaise? How? Let's see. As we move inside the earth, now no doubt the radius of earth is decreasing, but along with the radius of earth, mass of earth will also change. Now we are not taking into account the part that we have already moved. जो हमने डेप्थ में चले गए हैं, वो वाला पार्ट ऑफ अर्थ हम नहीं लेंगे. अब बीच वाला जो ओवल है, दैट विल बी द मास ऑफ द अर्थ नाउ. ठीक है, तो G will decrease. See, we will take the distance between the two objects. Now the object has moved inside. The distance between the two objects will be r minus h square. ठीक है, so the value again denominator has decreased. ठीक है, r minus h square, लेकिन mass also has decreased. Now we will take into account only the inner earth, and by calculation we get G will decrease with depth. So G will be maximum only at the surface. As we move up, G will decrease. As we move down, G will again decrease. Again, G is greater at poles and lesser at equator. आपको पता है हमारी अर्थ ओवल शेप्ड है, it is not circular. So As Earth has an oval shape, the radius at the equator is greater than the radius at the pole. अब ध्यान से देखो, radius at the pole is smaller, so value of g at the poles will be having the value with r smaller. Denominator smaller होगा इसमें. So if denominator is smaller, then the value of g will be greater. So at poles, value of g is greater. अभी मैं और समझाऊंगी, इसको डिटेल में करते हैं अभी. And at the equator, radius is larger, radius is greater, and the denominator is more. Here, for the equator, r will be more. The denominator increases, g value will decrease. So at the poles, g will be greater, and at the equator, g will be lesser. Why this happens? This question mostly comes in the paper. Why is Gp greater than Ge? Means acceleration due to gravity at pole is greater than the acceleration due to gravity at the equator. As we have discussed, Earth is in oval shaped. So the radius of the Earth at equator is greater than the radius of Earth at the pole. Slight फर्क होता है. तो जितना वो ज़्यादा होगा रेडियस, उस हिसाब से what will happen as Earth is slightly flattened at the poles and bulging at the equator. So radius of Earth at the pole is 21 kilometer less than that of the equator. ठीक है, 21 किलोमीटर का फर्क है from pole to equator. So RP, radius at the pole, is lesser from RE, that is radius at the equator, by 21 kilometers. Therefore, from the above equation, G and M being the same and small g is inversely proportional to the square of the radius, as we have discussed कि radius का inverse हो जाएगा g. If r is less, g will be more. So poles पे g more हो जाएगी. R is greater, g will be less. तो equator पे g कम हो जाएगी. Inverse relation है क्योंकि r is in the denominator in the formula for small g. So at the poles, value of g is 9.823 meter per second square. At the equator, it is 9.789 meter per second square. So averagely, we will take the value of g as 9.8 meter per second square. ठीक है, 9.8 ले लेंगे. अगली terms को हम छोड़ देंगे. Averagely, we take this. So students, this was all for today. And here is the task for you. Try to solve the back exercise, question number 7 to 11, that are given on in your NCERT book, page number 144. You can take the help from the video and also from the assignment number 3 given in this PDF page only. I have given you I have discussed these questions there also. So class, thank you and have a nice day. Thank you class.